Back again. Python crash course. Late night session tonight. Start 9:30. Very late for me. Got work tomorrow, but gotta get a session in. Didn't do anything all weekend, but goof around. So gotta grind a little bit. Gotta get some done. Chapter 4, working with lists. Should be good. It's gonna be talking about looping through access, and we already talked about accessing them, but further deep diving down that path. Exciting stuff. Python crash course. Eric Maths. Maths. Chapter 4. Excuse me. To go on do not disturb mode here. Alright. In Chapter 3, you learn how to make a simple list, and you learn how to work with the individual elements in the list. In this chapter, you'll learn how to loop through an entire list just with a few lines of code, regardless of how long the list is. Looping allows you to take the same action, so the same actions, do this, or set of actions, do this and this and this, with every item in the list. So do this and this and this with every item in the list, okay? As a result, you'll be able to work efficiently with lists in any length, including those with thousands or even millions of items, okay? So you can automatically do all these things to all of these things. Cool. Looping through an entire list. You'll often want to run through all entries in a list, performing the same task with each item. For example, in a game, you might want to remove every element from the screen by the same amount. In the list of numbers, you might want to perform the same statistical operation on every element. Or perhaps you want to display each headline from a list of articles on a website. When you want to do the same action with every item in a list, you can use a Python's for loop. Okay. Let's, oh, I need to start my timer. Shoot. How do I start it from the screen? Start? How do I just start? Play? Enter. Play? No? Oh, there it is. Start. Alright. Alright. Move this off to the side here. Great. Ooh. Can't have that. Why is it so large now? Interesting. I can't remove it from the screen either. Sorry, it's just eating my time here, but alright, whatever. Just gonna keep that down there. That's fine. Alright, a Python for loop. So let's go methods, definitions. Let's go below methods here. Or I want to go below functions here. Let's go, actually, right here. Loop. Okay. Get that. You have, this is me, just a definition. Come here. Go back. A definition or something. Blank space, and then we'll put here. For, or let's do quote for, okay. Or let's put it like this, for loops. Yeah, that's fine. Python's for loop. We say we have a list of magicians' names, and we want to print out each name in the list. We could do this by retrieving each name from the list individually. Okay, say we have a list of magicians' names, okay, a bunch of names, and we want to print out each name in the list. We could do this by retrieving each name, so we could do this by indexing into the list one by one, or we could do this by retrieving lists individually, but this approach could cause several problems. For one, it would be repetitive to do with a long list of names. Also, we'd have to change our code each time the list length changed. For a loop, using a for loop avoids both of these issues by letting Python manage these issues internally. Let's use a for loop to print out each name in a list of magicians. So magicians equals Alice, David, Carolina. For magician in magicians, print magician. So you use for variable in list. Your variable, I'm guessing, is any sort of, it's going to do. We begin by defining a list just as we did in chapter 3. Then we define a for loop. This line tells Python to pull a name from the list magicians and associate it with the variable name magician. Next, we'll tell Python to print the name that's just been assigned to magician. So for magician in magician, so it's going to pull for every magician in the list magicians. So I'm going to pull it out one by one, print the magician. So for every magician, Alice, boom, print. For every magician, David, boom, print. For every magician, Carolina, boom, print. Okay, gotcha. Next, we'll tell Python to print the name that's just been assigned a magician. Python then repeats the last two lines once for each name in the list. It might help to read this code as, for every magician in the list of magicians, print the magician's name. The output is a simple printout of each name in the list, Alice, David, Carolina. A closer look at looping. Looping is important because it's one of the most common ways a computer automates repetitive tasks. Okay. For example, in a simple loop where we used in magicians, Python initially reads the first line in the loop, for magician in magicians. This line tells Python to retrieve the first value from the list magicians and associate it with the variable magician. So it's basically it's, I need to actually go like this real quick, open up a new thing, or not. No, like, we want to go like this, close this, open up a new file, chapter _4, here. Let's open a new file. I'll just do test.py. So like for, you have a name equals quote list. Mike, David, Matt. And then it says basically, I'm sure we're going to do this for, this is names, for every name in our list names. What do we want to do for every name in our list names? Well, for every name in names, what do we want to do to it? Well, we want to print, just simply print the name, right? You can make smart variable names, like not name in this sense that it's the name variable because it's the list, right? But name as in naming your variables, in this case, names and name, is smart because, well, we have a list of names, which is plural, so we'll name it the singular form, name, to represent when it loops through and it pulls out a singular item, which happens to be, in this case, a name. Very easy to get just caught up in like these loops in your own head about, oh, I can't even figure this out and stuff, but it's all good. You gotta just keep pushing through and thinking about it. All right. Actually, let me open up I want to open up the chat and see if that is actually doing anything. Correct. Whatever. Cool. A closer look at looping. All right. So print magician. Python prints the current value of. Okay. So this line tells Python to retrieve the first value from the list of magicians and associate it with the variable magician. This first value is, quote, Alice. Python then reads the next line, print magician. Python prints the current value of magician, which is still, quote, Alice, a string, because the list contains more values. Python returns the first line of the loop for magician in magicians. Python retrieves the next name on the list, David, and associates that with the value of the variable magician as well. And it overwrites it. Python then executes the line, print magician again. Python prints the current value magician again, which is now, quote, David. Python repeats the entire loop once more for the last value in the list, Carolina. Because no more values are in the list, Python moves on to the next line in the program. In this case, nothing comes after the for loop, so the program ends. Interesting. Good. Yep, that's easy enough. When you're using loops for the first time, keep in mind that the set of steps is repeated once for each item in the list, no matter how many items are in the list. If you have 1,000,000 items in your list, Python repeats these steps 1,000,000 times, and usually very quickly. Also keep in mind when writing your own for loops that you can choose any name you want for your temporary variable, meaning the variable, like in this case, the singular form of names, or magician. No matter how many times, if you have 1,000,000. Also keep in mind when writing your own for loops that you can choose any name you want for the temporary variable that will be associated with each value in the list. However, it's helpful to choose a meaningful name that represents a single item from the list, like exactly what we explained earlier. For example, here's a good way to start a for loop for a list of cats, a list of dogs, and a general list of items. For cat in cats, for dog in dog, for item in list of items. These naming conventions can help you follow the actions of being done on each item with let me start that. These naming conventions can help you follow the actions being done on each item within a for loop. Using singular and plural names can help you identify whether a section of code is working with a single element from the list or the entire list. Okay, cool, simple enough. Doing more work within a for loop. You can do just about anything with each item in a for loop. Let's build the previous example by printing a message to each magician, telling them that they performed a great trick. Magicians, same thing as before. For magicians and magician, for magician and magicians, print f string magician.title. That was a great trick. So he's wanting to print. He's converting the magician's name to a title case, which is just the method.title will capitalize the first letter of the string, of every string in the phrase, and followed by that was a great trick. The only difference in this code is where we composed a message to each magician, starting with the magician's name. The first time through the loop, the value of magician is, quote, Alice. So Python starts the first message with the name, quote, Alice. The second time through, the message will begin with, quote, David. And the third time through, the message will begin with, quote, Carolina. The output shows a personalized message for each magician in the list. You can also write as many lines of code as you would like in the for loop. Every indented line following the line for magician in magicians is considered inside the for loop, and each indented line is executed once for each value in the list. Therefore, you can do as much work as you would like with each value in the list. Let's add a second line to our message telling each magician that we're looking forward to their next trick. So basically copies it over but just rephrases another print statement below it and says, I can't wait to see your next trick, magician title, \n. So he wants to create a new line. Because we have indented both call and print, because we have indented both calls to print, each line will be executed once for every magician in the list. The new line \n in the second print call inserts a blank line after each pass through the loop. Yeah, so every time it'll pass through blank lines to kind of just break it up. This creates a set of messages that are neatly grouped for each person in the list. You can use as many lines as you like in your for loops. In practice, you'll often find it useful to do a number of different operations with each item in the list. When you use a for loop, you can use as many lines as you would like in your for loops. Yep. In practice, you'll find it useful to do a number of different operations with each item in a list when you use your for loops. Okay. Doing something after a for loop. What happens once a for loop has finished executing? Usually you'll want to summarize a block of output or move on to other work that your program must accomplish. Any lines of code after the for loop that are not indented are executed once without repetition. Let's write a thank you to the group of magicians as a whole, thanking them for putting on an excellent show. So outside of the for loop, not indented, just in our regular, in the same, at the beginning of our program, not the beginning, but the same tab spacing of none, not inside the loop. Any lines of code after the for loop that are not indented are executed once without repetition. Okay, let's write a thank you statement. The first two calls to print are repeated once for each magician in the list, as you saw earlier. However, because the last line is not indented in the print, it's printed only once, because it's just read once in the program. Yeah. When you're processing data using a for loop, you'll find that it is a good way to summarize an operation that was performed on an entire data set. For example, you might want to use a for loop to initialize a game by running through a list of characters and displaying each character on the screen. You might then write additional code after this loop that displays a Play Now button after all the characters have been drawn to the screen. Avoiding indentation errors. Python uses indentation to determine how a line or group of lines is related to the rest of the program. So if it's has some sort of relation or interaction with the previous or statements, it's indented. In the previous examples, the lines that printed messages to the individual magicians were part of the for loop because they were indented. Python's use of indentations makes code very easy to read. Basically, it uses whitespace to force you to write neatly formatted code with a clear visual structure. In longer Python programs, you'll notice blocks of code indented at a few different levels. These indentation levels help you gain a general sense of the overall program's organization. As you begin to write code that relies on proper indentation, you'll need to watch for a few common indentation errors. For example, people sometimes indent lines of code that don't need to be indented or forget to indent lines of code that do. Seeing examples of these errors now will help you avoid them in the future and correct them when they do appear in your own programs. Let's examine some of the more common indentation errors. Okay, so this is another type of error here. In our program, let's go down, errors. Indentation error. Always indent the line after the for statement in a loop. If you forget, Python reminds you. So in this one, he just neglects to indent the print statement at the end here. So he has it like this, print, and it's doing it right here. It's telling me VS Code is. The call to print, in this case line 3 in my program, should be indented, but it's not. When Python expects an indented block and doesn't find one, it lets you know which line it had a problem with. Indentation. So if I run this program, boom, indentation error. Expected indent block for a for statement. Okay, cool. Easy enough. You can usually resolve this kind of indentation error by indenting the line or lines immediately after the for statement. Forgetting to indent additional lines. Sometimes your loop will run without errors but won't produce the expected result. This can happen when you're trying to do several tasks in a for loop and you forget to indent some of its lines. For example, this happens when we forget to indent the second line in the loop that tells each magician we're looking forward to their next trick. Magicians equals Alice, David, Carolina. For magician and magician. So he has this print name, print name again. We'll do that like this. Sorry, typing with one hand. So he has like it twice, but this one he leaves out. It'll print the name, right, again once, but it won't loop through again all of the names because it's not in the loop. I believe that's what's going to happen. I always forget where my place is. For example, he neglected to do that. Oh no, he just included the line that was supposed to be. So this was supposed to be like the thinking everyone. He included it in the for loop, right? If you accidentally indented a code that should have run after the for loop, will be repeated once for each line. Oh no, I think I skipped the whole page here. Oops. Getting tired, definitely. Timeout. Need a break here. 5 minutes left. Okay, keep going. Forgetting to indent additional lines. Sometimes your loop will run without any errors. Yep. The second call to print is supposed to be indented, but the Python finds at least one indented line after the for statement, so it doesn't report an error. As a result, the first print call is executed once for each name in the list because it is indented. Okay, just like before here. Inside the for loop, the one print name will get called each time. The second print call is not indented. This guy down here on line 4. So it's executed only once after the loop has finished running. Because the final value associated with magician is Carolina, she is the only one who receives the looking forward to the next trick message. So because Matt is the last person in the list, he'll get called twice at the end because he'll just say print Matt because he's the most recent storing of the variable name from our for loop. Most recent override. All right. He's the only one after the loop has finished running because the final value associated with which is Carolina. Yeah. This is a logical error. The syntax is valid Python code, but the code does not produce the desired result because a problem occurs in its logic. If you expect to see a certain action repeated once for each item in a list and it's executed only once, determine whether you need to simply indent a line or a group of lines. So if you're expecting it to print it multiple times, well, oftentimes it might just not be included in the for loop in the first place. Yeah. Okay. So this is go back. Indentation error. Just do a ABC here. I'll put that in later. And then we have a logic error. Not an actual error in Python, but I'll kind of formulate this later. I'm getting too tired. I think you might have to cut it after one Pomodoro timer here. I'm getting pretty sleepy. Indenting unnecessarily. If you accidentally indent a line that doesn't need to be indented, Python informs you about the unexpected indent. And just simply message equals hello Python world print message. You don't need to indent print at all because it isn't part of a loop. Hence, Python reports that error, indentation error. Okay, just like before. If you can avoid unexpected indentation errors by indenting only when you have specific reasons to do so. In the programs you're writing at this point, the only lines you should indent are the actions you want to repeat for each item in a for loop. So only indent when you want to include it in a for loop, basically. Easy enough. Really hounding this topic in. If you indenting unnecessarily after the loop. So if you accidentally include it. If you accidentally indent code that should run after a loop has finished, that code will be repeated once for each item in list. Sometimes this prompts Python to report an error, but often this will result in a logical error. For example, let's see what happens when it accidentally indent the line that thanked the magicians as a group for putting on the show. Because the last line is indented, it's printed once for each person in the list, instead of just once at the very end to include everybody. Yeah. This is another logical error. Logic error. Whatever, logical error. Logical error. This is another logical error because the one in quote forgetting to indent additional lines on page 54. Yep, just to the one here. Similar to the one in, yep. Because Python doesn't know what you're trying to accomplish with your code, it will run all the code that is written in valid syntax. If any action is repeated many times, get my timer here. Pause that. Pause. Okay. Let me finish up this page here. This is another logical error similar to the one in quote forgetting to indent additional lines on page 54, the previous page. Because Python doesn't know what you're trying to accomplish, it's just reading what you type, it will run all the code that is written in valid syntax. If it's valid, it'll read it. If any action is repeated many times when it should be executed only once, you probably need to unindent the code. So if it's repeating and you're like, why is it repeating? Well, it's probably included in a loop. Forgetting the colon. So in the for statement, in order to initialize a action to be included, you have to colon and then provide the indent. Okay. The colon at the end of a for statement tells Python to interpret the next line as the start of a loop. If you accidentally forget the colon, you'll get a syntax error because Python doesn't know exactly what you're trying to do. I'm almost to a good stopping place. Give me a second here. File, quote, magicians.py, line 2, for magicians and py, syntax error. Yeah, so it gives a syntax error because it's when needing a semi or a colon there. Python doesn't know if you simply forgot the colon or if you meant to write additional code to set up a more complex loop. If the interpreter can identify a possible fix, it will suggest one, like adding a colon at the end of a line, as it does here with the response expected, quote, colon, quote. Some errors have easy, obvious fixes thanks to the suggestions in Python's tracebacks. Some errors are much harder to resolve even when the eventual fix only involves a single character. Don't feel bad when a small fix takes a long time to find. You are absolutely not alone in this experience. All right, so that is a good place to stop this first Pomodoro session. I'm gonna see how I'm feeling after the 5 minutes if I'm game enough to keep going, but I'm hitting the fan here. We're on page 56, just at the try it yourself section, 4-1 pizzas. Um, I'm going to start labeling these files a little bit better for dash, including the numbers so I can refer back to them when I can. But I'm also going to make individual videos for each problem, just a quick little 2-minute video for each one, just to show how to do it and how I did it. Really simple. But yeah, so I'll see you guys in 5 minutes here. Oh, come on. Not 20. Come on, I thought I changed that. 05. Start. Water. should just print Matt twice. Right? Oh, I see what happened. I had this wrong the whole time. Whoops. My fault. I had a syntax error myself. Logic error, I mean. Logical error. Identifying concepts here. Learning logical error. That was a logical error. Let's go. There we go. And then if we do this. Print back twice. Alright. I think I'm going to call it there. Short stream. Quick and easy. Couple pages here. Chugging along though. Chapter 4. Moving. I'll be back tomorrow. You can guarantee that. I'll be back tomorrow. Hopefully someone joins me one of these days. This is just supposed to be basically a journal. Keep myself accountable, and if anybody else is in a similar situation and is wanting to learn programming and is at a similar level, or even wants to shed some advice and is at a higher level, I would love to hear it. I'm wanting to have some ideas for some of my own projects, and I want to execute them, but they're pretty advanced, and I've got to get the tools necessary to really carry them forward and put into action. So anyways, tired of yapping. I'll see you guys tomorrow. Later.